Hi, welcome to this Mrs. Park's Algebra 1 class. This is Chapter 6, Section 4, Elimination using Multiplication. Okay, so why are we doing this? The table shows the number of cars at Scott's Auto Repair Shop for each type of device, each type of service. So if you get repairs and maintenance, you have body and engine, and that's the number of cars they had to do. Okay, so the manager has allotted 1,110 minutes for body work and 570 minutes for engine work. The system 3R plus 4M equals 1,110 and 2R plus 2M equals 570 can be used to find the average time for each service. So elimination using multiplication. In the system above, neither variable can be eliminated by adding or subtracting. You can use multiplication to solve. Okay, so before the last section we used adding or subtracting. This case, there's nothing that looks alike, so you can't really add or subtract here. So what do we do? First thing we do, multiply at least one equation by a constant to get two equations that contain opposite terms. Step 2, add or subtract equations, eliminating one variable, then solve the equation. Step 3, substitute the value from step 2 into one of the equations and solve for the other variable. Write the solution as an ordered pair. So step 2 and 3 is really the same as the last section. We're just adding one more step by multiplying one of the equations. Oops. Again, it's going to make more sense when we go over this example. Alright, so here we have 5x plus 6y equals negative 8, 2x plus 3y equals negative 5. So nothing really matches up here where we can add or subtract. But if I were to multiply, let's see here, by negative 2, so if I made this into 6y, that would be really convenient, right? Or if I made it into negative 6y. So that's what they did here, multiply by negative 2. That means by negative 2 by everything in this equation. So 2x times negative 2 became negative 4x. 3y times negative 2 became negative 6y. And don't forget the other side of the equation. Negative 5 times negative 2 became 10. Now I made it look so that they can be added or subtracted. 6y plus negative 6y would eliminate. 5x plus negative 4x is x. Negative 8 plus 10 is 2. So now you found out x equals 2. So now the next step is the same as the previous section. You're going to put the x in one of these equations. They chose the second equation. So instead of x, you put 2. And that makes it 4. Plus 3y equals negative 5. Subtract by 4 on each side. And you have y equals negative 3. So here's your x, here is your y, so x is 2 and y is negative 3. Okay, so this is your turn. Okay, so a little hint here, I would multiply the second equation by 2 to make it 6x, and you can subtract everything. So multiply 2, multiply 2, multiply 2, subtract it, find x, and then find y. Number 2, it would be easy to make the q's look alike by multiplying by 2 on the top equation. So multiply 2, multiply 2, and multiply 2. Then you'll have 2q, where you can subtract these two and eliminate. So pause the video and make sure you do your turn numbers 1 and 2, and come back when you are done. Alright, here's a quick study tip. Choosing a variable to eliminate. Unless the problem is asking you for the value of a specific variable, you may use multiplication to eliminate either variable. So you can choose which one you want to do. Sometimes you have to multiply each equation by a different number in order to solve the equation. Okay. Here is another example. Multiply both equations to eliminate a variable. Use elimination to solve the system equations. So here, let's look at what they did for method 1. There's different ways to do this. So here, they multiply the top by 3, 12x, 6y, 24. multiply the bottom by negative 4, negative 12x, negative 12y, negative 36. They did this so that they can make the x's look alike and make it 12 x's. Okay, so they did multiplication at the top and the bottom by different number so that it'll match up to 12x. They got rid of that and found their y. Put the y in substitute for either one of these equations and then found their x. Okay, that was the first method. Again, everybody can choose different methods, whatever they feel is more comfortable. The second method they use, they want to make the y's look the same. Okay, so they chose 6y would be convenient. So they multiply by 3, 3, 3, became 12x, 6y, 24. The bottom part for this 3y to make it into 6y or negative 6y, they multiply by negative 2. So this negative 6, 18 is what became here. And then they eliminated the y and found x. Put the x in any one of those equations. They use the second one and find y. Okay. Answer is 1 and 2. Exactly the same answer as method 1. Okay, so here's your turn. Use elimination to solve each system equations. So that would have been your turn number 3. I apologize that there was not a label for this one. So this is your turn number 3. Oh, you know what? I'm sorry. This was something that I want to do together. I want to do one more example together. So cross that out. Okay, this is one more example we'll do together. So you can make either the x's make into 20x or make the y's into 6y. Okay, so I'm going to make this, let's do 6y. So the top portion, I'm going to multiply everything by 3. The bottom portion, I'm going to multiply everything by 2. Okay, so here we go. Multiply everything by 3. 12x plus 6y, negative 42. Bottom portion, multiply by 2 everything. 10x plus 6y equals negative 34. Okay, so now I made the x's, the y's look the same. They're both positive, so I'm going to subtract to eliminate that. 12x minus 10x, you have 2x. Negative 42 minus negative 34, that makes it plus 34. 34, 6, 7, 8, negative 8. Divided by 2, and you have x equals negative 4. So once I have my x, you can put it in any one of these equations, first or second, even these two, but it'd be easier to use a simplified one. So I'm going to use one of the equations here. I'm going to put in the 5x. Now it's 5 times negative 4 plus 3y equals negative 17. Okay, so this makes it negative 20 plus 3y equals negative 17. I'm going to add my 20 on each side. Eliminate it. You have 3y equals 3 divided by 3. And you have y equals 1. So my final answer here, right, in order pair, x comes first, negative 4 and 1 is my final answer. Okay, so here is your turn numbers 3 and 4. Pause the video, solve the answer, solve for the answer, and come back when you are done. Alright, real world example 3. Solve a system of equations. A person or aircraft traveling with the wind flies 520 miles in 4 hours. On a return trip, the plane takes 5 hours to travel the same distance. Find the speed of the airplane if the air is still. You are asked to find the speed of an airplane in still air. So let A, the rate of the airplane if the air is still. Let W be the rate of the wind. Okay, so you have A plus W, A minus W. And you have time 4 hours, and then you have return trip 5 hours. And the distance is the same. So you have A plus W times 4 equals 520. And you have A minus W times 5 equals 520. So those are our two equations. And when you use distributive property, you have 4A plus 4W equals 520. And you have 5A minus 5W equals 520. So we're going to multiply the top by 5 and the bottom by 4 to make the 20A. So you can subtract, oh, I'm sorry, they want to eliminate the W. Okay. So they made the W's look the same so they can add to get rid of the W's. You got 40A divided by 40 and A equals 117. Okay, so the rate of the airplane in still air is 117 miles per hour. Okay, so here's your turn. Number 5. Use elimination to solve the system equations. Canoeing. A canoeist travels 4 miles downstream in 1 hour. The return trip takes the canoeist 1.5 hours. Find the rate of the boat in still water. So just like the example we had the previous one, if you need to rewind and watch the video there, go ahead and do that and solve for number 5. Okay, and that's the end of the video. Once you're done, make sure you bring back that homework for credit. And thanks for watching.